Welcome everyone to our latest Food Safety for Farmers webinar. Today we're going to be discussing post-harvest water use on farms. This is a follow-up conversation and discussion to podcast episodes that we have available. So please visit our website for more information on those topics. Today, we're once again very lucky to have with us Dr. Keith Schneider, Professor of Food Safety at the University of Florida, and Dr. Michelle Danyluk, also Professor of Food Science at the University of Florida. I'm your host, Juan Carlos Rodriguez, and we're very grateful to both Keith and Michelle for joining us once again.
Great to be here.
Thanks for having us again.
So I want to remind everyone that this webinar series is supported by a grant from the Food Safety Outreach Program, made possible by the USDA National Institute of Food and Agriculture. The contents of the webinars are solely the responsibility of the authors and do not necessarily represent the official views of the USDA. This webinar is not legal advice. So for specific information on the Food Safety Modernization Act regulations, you can contact an attorney. Okay, so today we're going to be talking about post-harvest water use on farms, and we'll also we'll be discussing some of the questions and further concepts that farmers have sent us. And with that, I think we can sort of start with the first question to both Michelle and Keith. We hear a lot, farmers are asking, because either they have seen it on a website or they participated in a workshop and they want to know or perhaps understand better what we mean when we talk about preventative controls.
Yeah, so I'll start with this. And so Keith is laughing because we just came out of a 3-day workshop all about preventive controls. And we're laughing because we sort of interchangeably use the words preventive and preventative. And I think preventative is perfect here. Preventive controls is a different FSMA rule, but preventative controls is almost the same thing. And when we talk about it with farmers, what we're really talking about is putting controls or putting food safety systems in place on an operation to be able to proactively prevent contamination from happening or proactively prevent contamination that happens from sort of spreading throughout the crop, whatever they're harvesting. So when we talk about preventative controls, we're really talking about systems that are in place to prevent contamination from happening or getting worse. Keith, I don't know if you want to follow up on that at all.
That's pretty much it. Again, a lot of times what they're hearing or maybe hearing is the other rule and trying to figure out whether they're a farm or not. And that's still up for debate of what's the actual definition of a farm. But for farmers, again, when we talk about any type of preventive control, we're really just talking mitigation strategies. There's really nothing fancy about it. Preventing things from happening, any hazard that may be out there from getting to the consumer.
Okay, I think that that's clear enough. Thank you so much for that. So, and there's also one of the things that we discussed during the podcast episode were, the conditions that are right for bacterial growth. This particular slide is illustrating some of those conditions, but we understand that there are various factors that can contribute to bacterial growth. Would you mind, discussing with us and sharing with us, what, these conditions are and, what makes them adequate for their spread and their growth?
I'm going to start on this one. If you notice the words, we affectionately refer to this as Fat Tom, FATTOM.
Okay.
And that's how it's a good mnemonic for remembering these different characteristics that all help folks understand those things that are necessary for biological hazards to survive, thrive, and again, make it to the consumer. The first one being food. Again, whatever that item happens to be, whether it's high protein, high fat, will dictate what types of organisms are found there. Its acidity, again, how acid or how much base is in that will dictate how well something will grow. So fairly acidic things like lemons are going to be relatively more safe than, say, something like a carrot, which has a more neutral pH. Time and temperature is really easy. Again, anytime you cook something for safety in your oven, and again, whether it be, say, poultry, let's say, you cook at a certain temperature for a certain amount of time, and those two are usually linked together. Typically, you won't have time and temperature separated, but that's a regime. And the classic one that most people are familiar with is cooking. The other one that we can apply to this is refrigeration. Again, as long as we keep something cold, it will prevent the growth of particular pathogens. And if it's out at room temperature or at some temperature above, and the danger zone is 40 to 140, how long has it been out at that temperature? And again, those time and temperatures are always stuck together. And then you have oxygen. Some organisms like it, some don't. And again, we can control for a particular pathogen just by not putting it in a bag that's airtight. Airtight or oxygen free presents a problem for certain organisms, but it makes a really wonderful environment for others. And then lastly, moisture. The example I always give is a slice of bread and a saltine cracker, both made with flour and water. They're sitting on the counter, and after a couple of days, that bread is going to be all technicolor with mold growing all over it. And really, the only difference between that and the cracker is the amount of moisture that's in there, and we can control growth in food. And again, by removing or changing some of these parameters, we're able to make food safer. But even in a processing environment, if we don't have standing water around, we don't provide moisture for these things to utilize. And again, we can reduce the potential risk of microorganisms. So again, for the folks out there, just remember Fat Tom, and remember what that acronym means, and this will help you kind of figure out strategies to make your food safer.
Yeah, and to all follow up with Keith, right? For each one of these things, there are mitigations that you can do to prevent bacterial growth. And in manufactured foods, we often call those safe harbors. If you're below a certain acidity, or your food below a certain acidity, something might not grow. If your food is below a certain moisture level, something won't grow, or pathogens won't grow on it. If your food is below a certain refrigerator, pathogens won't grow on the product. And I think oxygen is a really neat one, right? It's the reason why we see vented mushroom containers, to not create that no oxygen environment that things can grow. And so you might, when you're thinking about these things and you're thinking about preventative controls, you might also hear the word safe harbor, and that just means making sure that your product has certain characteristics related to the Fat Tom acronym that really prevent, that really put it in a safe place so that pathogens could not grow on the product.
So I'm wondering, and of course, farmers do implement, numerous practices, on their farms, especially like during harvest. And it just comes to mind, if people are harvesting on a particular day when there's been sort of even, the night, a rain, or morning rain, and they're harvesting out in the field, and then they're doing greens or whatever they're doing, strawberries or some of these other things, and they got their containers, whether they're buckets or some of the baskets, like Michelle was describing, but they're leaving it in the field before taking it to the shed and to pack, and they're leaving it in the field for X number of hours. Do you run into that? Are there some things that you remind farmers about, making sure that, they're not, they're mindful of that, and that the conditions that we're talking about right now are not actually, those right conditions for bacterial growth? you know, on those crops or that produce.
Yeah, again, fat time really, to me, is for those more processed foods.
Okay.
We have the ability to control some of these. So one of the ones on this list, though, if you're talking about farmers, is really moisture.
Yes.
Standing water becomes a problem. Again, if things are damp and we have the correct environment, we're going to end up with you know, mold growth or other things that are going to cause spoilage of that food product.
Mm-hmm.
So controlling the amount of residual moisture, whether it be harvesting something immediately after rainfall versus during a dry, cool day.
Mm-hmm.
Those are the types of things that farmers need to do. And honestly, the things that you're going to be doing in the field really deal more with, I would think, cross-contamination, right?
Mm-hmm.
With potential sources of contamination they're going to find out there. The one thing that fat time will do, again, other than for our processed foods, is really, again, if we have something out there and it's really wet and damp, that just gives an opportunity for anything that might be on the surface to make it into their packing shed or their storage facility, and allow those things to grow now because it's all damp.
Yeah, cross-contamination. I think there's a lot of published work out there that shows that if you compare a wet environment to a dry environment, you get a lot more cross-contamination when things are wet. So again, harvesting dry produce, making sure that the harvest bins and the pick sacks and everything are as dry as hot possible, making sure employees' hands are not wet when they're doing those things. All those things are going to limit cross-contamination. And then also limit, like he said, getting into a packing area and preventing them from growing. Great.
And the growth of microorganisms is something that we've also discussed in our podcast episode. So the growth of bacteria, we understand, is associated with an increase in the number of cells, and the rate of bacterial growth depends on the level of contamination. Prevention is key based on, you know, what we see on the screen. Can you please maybe expand on this topic of, you know, how microorganisms propagate or how they grow, and what it is, some of the things that, you know, farmers need to be, you know, mindful of?
Well, okay, we'll go back to some basics here. One, when we talk about biological hazards, we break them up into three categories. One being bacteria, other being viruses, and the other being parasites. Good news is the last two, viruses and parasites, need a host to multiply. So if you find them in the environment, they typically are going to remain at a constant level and they're not going to grow. Bacteria, on the other hand, are quite good at multiplying. They can multiply and divide depending on how favorable the conditions are, anywhere from every 20 minutes to an hour. So if you figure on average every 30 minutes, if you have a very favorable environment, it's moist, maybe you have damaged food or products sitting in the field, culls that are being dropped in the field. What can end up happening is any bacteria that's out there can multiply rapidly. And overnight, a single cell or just a couple cells can grow up to be millions. And that's what we want to try to avoid. So in a field situation, again, there's not a whole lot of we can control, especially out in the environment. But what we can do, again, if there's any damaged product, again, that's just sitting around the field that people may be treading over and then walking from one area to the next, they can be helping spread these organisms around. So in the field, if we see fecal contamination on the ground, just treading through that and moving it to different locations. We want to keep the bacterial pathogens as isolated or as segregated as possible. Again, we want to do all those things that are going to help prevent these things or a small problem from becoming a large problem. So in a field situation, again, we want to reduce the potential for animal ingress. So again, getting culls out there that would prevent animals from getting in there. Maybe that's even putting up fencing or some type of animal deterrent. If we're harvesting, we don't want to have culls laying on the ground where workers can be stepping on something. And again, those culls are going to be vehicles for actually growing these microorganisms. And again, then if they're stepped on or whatever, you can start transferring those things around the field. So growth of microorganisms happens really quickly. Again, this is why we don't leave food out overnight. We refrigerate things. That's the way we're going to prevent growth. So in the field situation, keeping it clean, trying to keep the animals out is our sort of number one priority, and also using clean water. Once it's in a packing shed or in the home, again, now we're talking about maintaining the proper temperature for that item, maybe storing in the refrigerator if it's a commodity that can be stored in the refrigerator. And then if we start processing it, make sure we keep an eye on what pH, how acidic or basic that is, whether or not we're putting in a jar or a can. We want to make sure what the oxygen requirement is. So there's a lot of things they can do, but just one of the things we're trying to control is the world is full of microbes. We're never going to get rid of them all. Matter of fact, most of them we need. But what we want to do is keep those things to as small a number as possible, and that will sort of prevent a very small problem from becoming a very large one.
Yeah, and I think Keith answered that perfectly. I'll just follow up. When he says they grow fast, he means they grow really fast. Bacteria grow in something called an exponential manner. So 1 become 2, 2 become 4, 4 become 8, 8 become 16, and 16 become 32, 64, 128, 256. It's very, very rapidly that you get this doubling effect. So a small problem can become a really big problem under the right conditions really quickly. So our best bet is to keep them from being there.
So and since we've been talking about microorganisms and these pathogens, we hear a lot about Cyclospora. Is this an emerging pathogen? And is there any research or known preventative measures for Cyclospora?
So I'll start on this one, Keith, unless you really want to. So Cyclospora is, and Keith doesn't really want to, so I can say that Cyclospora is a parasite, and so again, it's in one of those classes of microorganisms that Keith talked about, where it only grows inside a host. And when we talk about Cyclospora, there's only one of the Cyclosporas. Cyclospora is a genus of parasites. There's only one specific type of Cyclospora that is a human pathogen, and that's Cyclospora cayentinensis. Did I say that right, Keith? I always struggle with that one.
You nailed it.
Cayentinensis. So it's only that one type of Cyclospora that we're worried about, and so the thing about it is that when we talk about Cyclospora, we mean Cyclospora cayentinensis. And the thing about it is, as of today, our best science tells us that it's a human obligate pathogen. So what that means is that when we hear about Cyclospora, we need to immediately associate that with human fecal matter. That's where Cyclospora comes from. It's only passed from human to human. It doesn't go through any animal host that we know from. So if we've got a Cyclospora problem, it means we have a human feces problem. And so the second question there is really interesting. Is this an emerging pathogen? So we've seen Cyclospora outbreaks going back a couple of decades at this point, right, Keith? And historically, they've always been linked to product being imported from other parts of the world, particularly Latin America, is where we saw a lot of those products being implicated from. But Cyclospora is a tricky organism because it causes gastroenteritis, so high volumes of watery diarrhea, but it doesn't kill a lot of people. And people can even be asymptomatic for Cyclospora. And our methods for finding Cyclospora, both us as people looking for Cyclospora in food contamination, and for doctors diagnosing Cyclospora in patients with diarrhea in the hospital, keep getting better and better and better. And so because of that, since I think 2018, we've started to see outbreaks of domestic produce linked to Cyclospora. So it's not just a problem with imported product anymore, where again, it's been a recognized risk for many years. We're now seeing it also in domestic product that's being grown and harvested here in the United States. And I think the first time we saw that was back in 2018. The bottom question is the most interesting, because the question is there any research or known preventative measures against Cyclospora? And again, that is where you have to think back to Cyclospora only comes from human to human. So we're looking specifically at human feces. And so what we know about preventative measures on Cyclospora is we know we need to control human feces. So you need to think about any sources in your farming operation where there could be human feces. And the ones we point to the most frequently are proper hand washing of workers, right? We need our workers to be very careful to know that even if they're not sick, they can still be spreading Cyclospora, and that they need to be really careful about hand washing. They need to be really careful about, contaminating their clothes and bringing any of that out into the field. When we talk about also those portable restrooms, we need to be really careful about where we might be cleaning them out or servicing them, right? We need to be really careful that they're not, when they're being serviced, are not splashing into our field sources at all. We need to be really careful that our workers are using those restrooms. And again, I think we're very good across the produce industry at much advanced from where we were 3 or 4 decades ago in terms of employees using those porta potties. And then we need to look at our water and our soil sources and see if there's any opportunity for human feces to be contaminating those sources, either through just discharge from a municipal system or through septic leakage. But the preventative measures we have to follow or need to think about for Cyclospora really link back to preventing its spread from humans onto our crop. And I'm sure Keith has more to jump in and add there.
Yeah, so I'm going to, again, good summary. One of the things, isn't an emerging pathogen. It's been around for a very long time. I think when we say emerging pathogen is really just a switch from mindset of this being something coming from a developing nation to being domestically sourced. If we look at the absolute numbers of this, we're talking about maybe 2,000, 2,500 cases a year compared to, say, salmonella, which is about 1 million to 1.5 million. So this is not something that, when you look at the sheer numbers of it, I don't think that's even in any comparison, or a pathogenic E. coli. I think what people have noticed, again, in the shifts or the Gestalt shift here is that, we now have this pathogen maybe from a domestic source. And that seems kind of odd because, again, the only way we can transmit this is through human feces. We think we're, as a very developed nation, we're not have any raw sewage getting into our irrigation waters. And the concern now is to figure out where it's coming from. Are we having residential areas encroaching so close to our production areas that there may be some, whether through septic tanks or liquid sewage lines, that this may be getting into the waters. But the mitigation strategies, just like Michelle outlined, really, one, it's more resistant, so we can't go around treating the water with chlorine, which is what we normally do for bacterial pathogens. This tends to, the oocysts or the eggs tend to be a little bit more resistant. So now we're stuck with, again, preventing that human fecal contamination from getting to the crop. So good agricultural practices, maybe limiting overhead irrigation, making sure, again, our porta potties are far away and we're not draining them in the production field. So again, just kind of keep it, for me, just keeping in perspective. We don't want anybody to get sick, even if it's something like Cyclospora, because again, somebody who does get sick may be sick for a month or even 2. Even though it's not a deadly pathogen. The sheer numbers are extremely low, but I think why we're seeing this is just because now we have this mindset shift that this was only an import problem, but now we're seeing it as a domestic issue potentially. And now we need to figure out, why we're seeing it all of a sudden. And that just may be changes the way we're doing agriculture, or we're just getting better at finding it. That could be just another reason where it's a really hard thing to find. There's very few people who work on this, and we're just getting better at microbiology, and maybe that's where we're seeing it more, just because our techniques have just gotten better.
Right, right. Okay, thank you. That is very useful in clarifying, what Cyclospora is, how common it is, and how to prevent it. That was very, very useful. Thank you. In the podcast episode where we discussed post-harvest water use, we were talking about the quality and why the quality of the post-harvest water is important. We also talked about and mentioned it already, cross-contamination. And we also touched on the use of sanitizer. So these were some of the things that we discussed during that episode. In the few following slides, we want to discuss them in a little bit more in depth. Is there anything that you want to remind our people tuning into the webinar today about, the importance of post-harvest water quality and contamination right now?
I think the one point that we stressed during that podcast, post-harvest water use is one of the, or has the biggest potential for making a small problem into a very large problem. We want to make sure our water is clean. Again, we're never going to get rid of all the microorganisms that are out to get us, even though those are small. But if we make sure that the water is clean and we use it correctly, the chance of those getting to an individual and actually causing illness are low. So as long as we have control over the water that we're using during and after harvest, again, the chance of that contributing to a foodborne illness or an outbreak becomes very, very low.
Mm-hmm. So here it is. So we're talking about water quality, and during the podcast we were talking about eliminating pathogens in the field if possible, and the improper use of harvest and post-harvest water use is also very important. As you pointed out, it can make a small problem into a much, much, much larger problem. We have to use clean water. I think that goes without saying, to control contamination, any type of contamination. I believe, and I wonder if the two of you can sort of provide a little bit more information on the produce safety rule. But I think that the rule says that no detectable generic E. coli per 100 mL per sample. What does that mean exactly?
Yeah, so the produce safety rule does say you have to use water in all your post-harvest applications where there is no detectable generic E. coli per 100 mils. And so what that requires is that the person using the water in the post-harvest environment, both for washing off crops and also for washing off all your equipment that contacts those crops, be either come from a municipal source where it is treated to meet drinking water standards, come from a groundwater source where your well water would meet this no E. coli per 100 mils, which most of the time we would expect wells to meet, because if a well is properly constructed and into a good aquifer, the water coming out is very safe. Or any surface water that you would use would need to be treated by you to meet that standard. The tricky thing about this standard is that you need to keep that no E. coli per 100 mil sample if you're reusing or recirculating the water. So if you have water in some sort of a sink or a dump tank where you're putting product in and putting multiple times product in, you have to keep that water at no detectable generic E. coli per 100 mils over the course of your operation. And so the rule does not require you to use a sanitizer, but there really is no other way to keep reused water in your operation at that standard. And so while it doesn't require you to use a sanitizer, if you are reusing water, the only way to meet that requirement is to use a sanitizer. And this is to make sure that those water sources, either again touching our crop during washing or touching those food contact surfaces or that we use to wash our hands, are not a source of contamination into the water, because we know we have any number of outbreaks we can point at related to fresh produce where breakdown of where the water system in the post-harvest environment was a source of contamination, turned a small problem into a much bigger problem, and then resulted in the outbreak.
Mm-hmm. So I think that partly answers this next question that you were referring to, Michelle, when it comes to sanitizers. With reusing or recirculating water, then let's say that, for instance, a farmer has brought greens from the field and has 3 sinks in where he's washing, the produce or the lettuce or the greens. Would the farmer need to use sanitizers in any of those things, or how does that exactly work, or what are some of the things that you guys recommend and tell farmers to sort of keep in mind?
So the rule states you don't have to use a sanitizer.
Uh-huh.
Just have to maintain that the water is clean. So you're sort of at well, how do I do that? Well, you use a sanitizer. So even though the law doesn't require you to use it, it's still a good idea.
Okay.
Now, the use of a sanitizer also has another benefit. First off, the legal definition of why we'd use it. The whole idea here is we're not washing the produce, we're preventing cross-contamination.
Mm-hmm.
Now, if I use a sanitizer in my rinse water, am I actually cleaning the produce? Yeah, typically I am. But from a legal standpoint, since I can't guarantee I'm going to get that product completely pathogen-free, I'm going to remove all the harmful organisms. I can't say that I'm actually sanitizing the fruit. Now, if I use a sanitizer, especially in a recirculating system that Michelle just talked about, and I keep it at the proper levels, what I can guarantee with pretty much certain 100% certainty is that I'm not going to have a pathogen that may be present on one piece of fruit transfer to an uncontaminated piece of fruit.
Mm-hmm.
So that's something I can guarantee.
Mm-hmm.
So when we talk about using sanitizers, one of the big reasons is we're trying to prevent cross-contamination. That's the first reason. The second really important reason is if you keep using water on a surface and you don't clean it on a regular basis, or you're not using a sanitizer, you can build up something known as a biofilm. And these biofilms are colonies of microorganisms that, again, will grow on anything. You have to go to any sink or drain in your home and look at the slimy coating that's all over it. That's a biofilm that you have in your home. And for the most part, most biofilms are benign, but if you're in a processing environment, those biofilms can actually act as protective barriers or hiding places for potentially harmful microorganisms. So we don't want to build up biofilms that can potentially harbor or protect pathogens. So again, the use of sanitizers helps remove or prevent them from being established. So again, don't need to use them. We highly recommend that you do, though.
Mm-hmm. Okay.
Yeah, and I think if you move on to the next slide, we can follow up on this again. Keith always tells folks to go home and run their finger in the bottom of their dog bowl or around the drain in their house. Don't do it, guys. It's really gross. But what you are feeling is biofilms. Every time we teach, he's like, go run your finger around it. I'm like, don't do it. It's so gross. But I think that is a key point, even if you're using single pass water, right? Is that if you're using single pass water and you're spraying it on a surface over and over, and I think in my mind, like spraying on, if you're running a brush roller or some type of an overhead spray, that sanitizer in that water, although it's not recirculated, will help those biofilms from building up over time. And I think that's a really important use of sanitizers and a reason why someone might want to put a sanitizer into their post-harvest water. Yeah.
Mm-hmm. Mm-hmm. Yeah, thank you for explaining further. That is a really good illustration. And like you, would probably don't want to be running my hand in my dog's bowl because, I know how dirty that can get sometimes, even though we try to keep it clean all the time. So we're talking about sanitizing, but we also mentioned, washing. What are the differences between cleaning, washing, sanitizing, and even disinfecting, which is another term that typically hear or that we use all the time, and that we think that they're all the same. But I'm assuming that they are not.
So typically 3 terms we use sort of synonymously, and they mean different things. We say sanitizing, disinfecting, and sterilizing. Sterilizing is, I always kind of think of that when we're trying to maybe can food, or even a surgical operation or something like that. That's the removal of all vegetative or actively growing microorganisms. And it also means the removal of spore-forming microorganisms, which are very hard to get rid of. Things like Bacillus cereus or Clostridium botulinum, something really resistant to cleaning. So when we sterilize something, we're getting rid of everything. When we disinfect, typically what we're talking about is removing all those vegetative or actively growing microorganisms. We may not, get rid of those hard to inactivate spores, but we're getting rid of most of the pathogens of concerns, the Salmonella and E. coli. When we're sanitizing, this is much less rigorous. This is really just removing the microbes to a level that's going to result in a safe product. It doesn't mean getting rid of all of them. It just means that we're going to get the microbes down to a level that is not going to result in illness or injury. So typically when we're sanitizing a surface, again, we're giving it a nice good cleaning, and the resulting or remaining microbes are not going to end up making somebody sick. So that's those are those 3 terms. Now, the other ones, when we talk about when we're cleaning surfaces, whether in the home or on the farm, or even in a packing facility, the first thing typically we do sort of a 3 to 5 step program. The first thing you want to do is you want to clean a surface, which gets rid of all the debris and easily kind of materials that can be washed off or wiped off. And that gets rid of the soil. And once you clean a surface, now we can effectively go in there and sanitize it. Technically, you can't sanitize a surface that hasn't been cleaned. We want to get all that debris off. So typically we'll go in, we'll clean a surface. We may rinse it down, we'll sanitize it, and we may go back with another fresh water rinse and then maybe rinse that sanitizer off. But typically, we want to clean a surface before we actually go in and do the sanitizer. If you don't clean something off, and I always give the analogy of when you're putting stuff into your dishwasher, and either I don't have a very good dishwasher, or again, maybe I'm doing it right. But what I do is I wash my dishes off first. I get rid of all the physical debris. That way, when I put them in the dishwasher, the cleaning, washing, and sanitizing step that happens in there is much more effective. If there's food residue left on those plates or forks, and it doesn't get washed off, maybe it's a little bit too dry or sticky or whatever, I can't properly sanitize whatever I'm trying to clean. So to me, it's sort of the same idea of, pre-washing those dishes and utensils before going into the dishwasher.
Mm-hmm.
You need to get a better dishwasher, Keith, or better dish soap. No, I 100% behind what Keith said. Cleaning really is key, and it's really the first step. And it really is, the goal is to remove all the visible filth you can see from the line. So you really want to make sure you're removing any plant debris, any buildup of wax or anything else. And cleaning has to come first. And cleaning is what's required by the produce safety rule. So if you read the rule, it says clean and sanitize is necessary. So cleaning really needs to be the gold standard that growers need to work towards. And I think that, that visible clean check, that when you're done cleaning something, you shouldn't be able to see that food debris that Keith talked about on your dishes. And if you can't get to that, then you're really wasting your time with the sanitizer afterwards. You're just throwing money away, because that sanitizer is going to interact with all the plant material left on those lines, and instead of interacting with the bacteria left there, that'll just deactivate it. So cleaning and then sanitizing is necessary. And I'll say cleaning and then sanitizing is what you need to do a clean break, but cleaning is the requirement really in the rule. Disinfection, not the only time I think we ever saw it come into play was as COVID was starting, and we wanted to disinfect surfaces to make sure COVID wasn't a variable in play, but really we're talking about cleaning and sanitizing, and really cleaning and sanitizing when necessary.
Mhm. And I guess this really does also, because we're talking about surfaces here, but applies to when we were talking about, um, people working out in the field, farm workers, everybody who's basically handling produce, crops. When we're talking about, washing their hands, if their hands are very, very dirty. And people sometimes use those sanitizers and think that their hands are clean sometimes. It's the same thing, isn't it? If you're not doing properly wash and clean your hands before you use something else, rubbing alcohol or something else, that really isn't, a very effective way to prevent those organisms from spreading.
Yeah, just think about it. If your hands were covered with dirt
Yeah,
and then you use a hand sanitizer,
yeah,
that alcohol is going to start reacting with all that soil that's on your hands.
yeah.
The microbes may be hiding underneath it. So once you're done using that hand sanitizer, again, you still have a ton of bacteria left on your hands. Now, if you use soap and water first and you remove all that soil, now when you use that hand sanitizer, the only thing left is those organisms on your skin. And 100% of that effort is going to go through inactivating what's left. So the cleaner something is, the better our sanitizing agent is going to be, the more efficacious it's going to be.
Mhm. So other considerations are things that I hoping that we can sort of cover. Um, if we're going to use any sanitizer, I understand it must be EPA approved and labeled for that particular use, intended use. That farmers should have or must have written standard operating procedures when a sanitizer is used. They have to monitor and also use proper storage. And this is all, again, things that we discuss during our podcast episode, which I remind people to, go and listen to. Any produce that you apply that affects food safety and it needs to be monitored, and you basically need to keep records for that. And also, very, very important that you need to have a plan for when something goes wrong. In other words, a corrective action. Would you mind maybe expanding on these considerations a little bit more so people can understand why they're so important?
Sure. Okay, so sanitizers are regulated by the EPA, Environmental Protection Agency. So therefore, anytime you're using anything on a food contact surface or on actual edible product itself, you want to make sure that it's approved by EPA. That means it's been tested and shown to be safe. There's a lot of chemicals out there that we use that do wonderful for cleaning tables or washing your floor that I don't want to put on my produce. I don't want to wash my my food in those particular chemicals. So the first thing we do is look for an EPA registration. Second, we want to make sure that it's labeled for its intended use. Again, you look on the bottle or container, make sure it says for use in agricultural water, used for washing vegetables and fruits. But you want to make sure that, again, that this chemical, whatever you happen to be using, is safe and is labeled for its intended use. That's the proper thing. One of the things we often don't talk about, though, is how to use it properly. So I may be using sodium hypochlorite, and you may know that as bleach. And maybe we have food grade bleach. It says on the label, we can use this for washing fruits and vegetables. Great, we've hit two of the major concerns. Now I have to be able to use that chemical properly. And having a written standard operating procedure is the way to go, because one, we want to use it according to the manufacturer's instructions. And sometimes, again, if people are using a chemical that they're not familiar with, they may not use it at the proper concentration. If it's too low, it may not prevent that cross-contamination that Michelle and I have been talking about. If we use too much, now we may get residues on that fruit or produce that may make it to the consumer. So having those written standard operating procedures helps anybody who happens to be using those chemicals using them properly. It also helps protect the worker. Again, if it says, don gloves before using. This may help prevent chemical burn. So written procedures are always a nice thing to have around because they help things go according to plan. But anytime we have a procedure now, we want to be able to monitor that we're doing it correctly. Again, those procedures that we put in place, we want to have a written record that we've done them, just in case anybody asks. We can show that we've done that procedure, we've done it correctly, we've used the proper chemistry at the proper concentration for the proper time necessary to prevent that cross-contamination. The storage issue you have there is just, again, you always want to store stuff safely. You never want to store maybe a toxic chemical. I always go back to the kitchen. You never store bleach up on the top counter, right? Because it can always fall down.
That's true.
First thing we worry about is falling down and getting into your eyes. That's the first thing. Yeah. Two, you don't want to store it where a child can get it, right? Because again, that can be dangerous. Same thing goes on a farm. You don't want to store chemistry where somebody who's not familiar with it, or God forbid, somebody wants to do you harm, can get at a chemical that can be dangerous and use it inappropriately. So proper storage, typically in a locked or restricted area, is always a great idea. But any procedure that you do on a farm, in a packing shed, you always want to make sure that you're doing it correctly, and we do that with monitoring. That frequency is a little bit up in the air. There's no prescribed frequency, and you get to set that. And if you don't know, we can always help you out to help determine that. But let's just say we do it every hour, and then when we do those monitoring steps, making sure we have the proper concentration, we always keep records. And that's in any business, especially with food. Anything that you do that is going to improve or protect the safety of a product, we want to keep a record of that. With that said, again, the bottom bullet point here is have a plan for when something goes wrong, and something always goes wrong. The longer you do something, or the larger your operation is, inevitably something will go wrong. You'll get out there and you'll be doing an hourly check, and you realize that the chemistry that you've selected isn't at the proper concentration you thought it should be. Have a plan in place before that happens. What am I going to do with that product? Is it still safe? These are the type of things that, if you plan for things to go wrong, when something does inevitably go wrong, you're not panicking. You're putting that plan in place. You're limiting the amount of product that is exposed or is potentially at risk. And again, that just reduces the potential for somebody getting ill. And that's the ultimate goal. We all want to produce safe food, and having corrective action plans already thought out. Just think anything that possibly can go wrong. Even how silly it is, write a small paragraph on how you deal with that. And then when it does happen, which it might, again, you can just kind of pull that out of the files and institute your plan. And that puts the smallest amount of product at risk.
So I want to go back and talk about that labeled for its intended use from the very beginning. And Keith mentioned that bleach, right? The high sodium hypochlorite might be something that you're using for your sanitizing, either in your wash water or even on your surfaces. And the only difference between the bleach you buy for your laundry and the bleach you buy that's labeled for food contact or for food use has to do with its level of purity. And so that higher level of purity is why the ones that are labeled for food use can be a little bit more expensive. There's a reason that we want to use that higher quality chemical for washing and cleaning and sanitizing, and beyond just that, whatever Cotton Clean or Rain Scent or Meadow Breeze or whatever the label on our bleach label is, it is the scent, is not really maybe something that you want on your produce or on your packing line. And again, Keith and I don't think you're sure exactly what the chemicals are that make Rain Scent or Meadow Breeze that we see in those cleaners. Those are not chemicals that are safe for use on fresh produce. And so we really don't want those things in our fresh produce, which is why it's so important to make sure we get a product labeled that is at a level of purity that is safe for us to consume. At very low levels. And in some of the cheaper brands that we see, and I think Keith, both and I have seen some inappropriate brands of bleach on packing lines across the country. We want product that's got the purity to be on those lines, and a lot of the ones that we can go down and buy at our local super centers don't always have that purity. So it's really important to make sure that the chemical you're using is labeled for its intended use.
And that's so important, and thank you so much for pointing that out. And in fact, that brings us to a question that we typically get from farmers is the specific chemical or substance that are being used. They're either more expensive. We're talking about a higher level of purity, which in the case of sodium hypochlorite bleach, that may be a little bit more expensive, correct? So if people may be out there looking for alternative or cheaper products, and is there something that they need to keep in mind and still meet the FSMA requirements when it comes to chemicals and substances?
Oh, each chemical is going to have its own pros and cons to it.
Right.
One has to be food grade, even if it's more expensive. So that's one of those things Michelle just pointed out.
Right.
There are cheaper forms of bleach out there. If they're not food grade, you don't want to use them. Again, it's just something, the cost of doing business. There can be, and it may be maybe the same brand, and it may be made in the same factory, but you can't guarantee again that there aren't impurities in there that, again, if a consumer were to consume them or consume enough of them over time, that it wouldn't cause harm, and we don't want to do that. But there may be chemicals that are more expensive, but may last longer. So that's one of those things where sometimes, you may see something with a higher price tag, but just maybe more effective, and I don't have to use as high an amount. Maybe I'm using chlorine, but I have to use twice as much if I was using a peroxyacetic acid. I would explore the different chemistries that are available, especially for organic production. There are some that are like peroxyacetic acids that can be used in organic production. Different vendors may have different pricing, so look around for those different products. But again, the ultimate thing here is looking for those chemistries that are food grade, and then I guess shopping for the best bargain within that subset.
Yeah, and I'd follow up with Keith to say, there are a bunch of chemical supply companies out there for the food industry, and they are people that have high technical level of skills most of the time with their products and are able to offer technical support. So reach out to them. If you are a very small operation and you can't find a vendor, even somewhere like a restaurant supply store is somewhere that you could purchase a lot of food sanitizers labeled for food use or for on-food contact surfaces. So there are options out there. There are options out there as long as they're labeled for food or food contact surfaces, then they would still meet any requirements in the rule. You just want to be really careful when you're using something that's not labeled.
And that actually brings us to the last question, and one that may be related. And as we're talking about costs and prices of sanitizers, substances, and other things, does the USDA or FDA or other organizations that you might know of offer financial assistance either for testing or for some of the other things that farmers are doing to keep our food safe?
The top of my head for testing, no. Now there are programs to help farmers make sure that their facilities are ready for inspection, things like the on-farm readiness review. And I'll let Michelle talk about that. Something to consider is that the testing requirements that were written into the produce safety rule are being readdressed. So the water testing that was required, but always put off until the future, now looks like maybe going away, and there may be some other type of risk assessment that's going to be done. So the need for testing may actually drop precipitously in the near future. We don't know. That's still in flux.
Okay.
But as far as offering direct financial assistance, I'm not aware of any program that does that. Michelle, you might know. The one thing, again, helping farmers get ready for inspections, we do have something known as the On-Farm Readiness Review, which is in fact a program that is, I believe it is free.
Mm-hmm.
Free. Yeah. So I also am unaware of anything right now, at least within the state of Florida, where anyone is offering financial assistance for testing. I do know that there are cost share programs that have been done in the past, but that's typically not for testing, but something like for facility upgrades or upgrading. And I know, especially early on in COVID, we saw a fair amount of money available at the county level for upgrading things like hand washing facilities.
Mm-hmm.
But testing is a little bit tricky. I'm not aware of it. That doesn't mean it doesn't exist, but I'm just not aware of it.
Mm-hmm.
Like Keith did mention, there is this on-farm readiness review program, and that's a free program that's offered in most states in the country. Here in Florida, it's a collaboration between us at the University of Florida and the folks over at the Florida Department of Ag and Consumer Services, or FDACS, where you call up FDACS, and I think there's a link on their website, and you can request that somebody from UF and somebody from FDACS come out and walk around your organization with you and check you, sort of like another set of eyes on your operation, to let you know what you're doing that is in compliance with the rule and what steps you might want to take prior to an inspection to get closer aligned to the rule. So they do a pretty good job of pointing out areas, both where you're doing really well and what you're doing is in line with what the rule is, but then also highlight areas that you should consider for improvements or changes to be more compliant with the rule. And again, currently a free service, and we see that a lot of growers that go through it really get a lot out of it. It's always great to have another set of eyes on your operation to see what's going on and offer insight. And in this case, yeah, it's a free program right now, so I'd encourage everyone to take advantage of it.
Absolutely, and thank you so much for actually bringing this up, because when it comes to financial assistance or things that are helpful, the on-farm readiness is one of those, and we are going to have as part of the series, our food safety series, conversations about the on-farm readiness very soon. So stay tuned, because that is something that we want to share with all of you and provide more information, and specifically in this case on the on-farm readiness, which I think many of you will take advantage of, hopefully. I just want to end with reminding people of some of the resources, a lot of the topics and conversations we have had in the past episodes. And today, you can find more information by visiting the FDA's website, which is up on this slide. That's a resource that I encourage people to use. Of course, the University of Florida Southern Center, where Michelle and Keith, work and are a part of, is a very, very useful resource. We invite people to visit their website as well. We want to thank them once again for taking the time to talk to us. They're, to us here at Florida Organic Growers, invaluable partners. They've been helping us over the years understand the FSMA regulations and what's required, and sharing that information with our farmers. So we really, really appreciate both of you for all of the excellent work that you do. And we invite everybody listening today's webinar to visit their website and understand more of some of the work that they're doing. We also want to remind everyone that to please visit our website for more information on our podcast and upcoming webinars. We really appreciate it, everyone tuning in today, joining us for this very important discussion. We really appreciate it. And once again, we thank you, Keith and Michelle, for talking to us today.
Thank you. Great to be here.
Yeah, thanks for having us.